Hello, my name is Allyson Bieryla. I'm an astronomer at the Center for Astrophysics, Harvard and Smithsonian. Really excited to get to talk to you about a project that I've been working on for a number of years now. I'd like to take a moment just to acknowledge the hard work of my collaborators. Soleil Hyman was an undergrad at Harvard. She did a ton of work on the software and hardware development on the LightSound and documentation. She's now a graduate student at the University of Arizona. Beatrice Garcia has led all the efforts in Argentina, and Paulina Trancasco or Baron led all the Chile efforts. So this is LightSound 2020 Experience, the Great Total Solar Eclipse in Chile and Argentina. So what is LightSound? Really, it's a sonification device designed specifically for solar eclipses. And by sonification, I just mean simply converting light to sound. So this is a tool that we designed as a way for blind or low vision individuals to be able to observe the solar eclipse via sound. And sighted individuals can also benefit from this device using sound to observe. And often these multimodal observations bring out subtleties in data that you might miss by just visually inspecting the data. So the intention of this project was always to keep it low cost. This device shown here in this version is about $70. We want everything to be open source, so all the software and code is available online, and the instructions, very detailed instructions for building and using this device, are available online in both English and Spanish, and we hope to expand that to other languages. Briefly, this schematic here kind of shows the insides of the device. Essentially, this audio output you can attach to headphones or speaker. There's this light sensor that's very high dynamic range, so it doesn't saturate in bright light. In the brightest of sunlight, it might saturate, but really we were interested in the lower light range. So when the moon eclipses the sun, it's about the brightness of a full moon, and in those levels, the sensor is still sensitive. So we got the sensor, and then this microcontroller has the software on it that takes that light measurement and converts it to sound. And using the MIDI synthesizer, we can assign different instruments to the sound to make it a pleasant sound. And it's about the size of a smartphone, so you can hold it in your hand. It can run off a 9-volt battery, or you can also plug it into a computer via the USB port. And if it is plugged into the computer, it not only powers the device, but you can also collect data to later sonify and analyze. So I want to play just a couple of quick sound clips so you get a listen to what this is doing. It's kind of simulating an eclipse. So this circle will move over the light sensor and you hear the light change. So this first clip is playing the just basic instruments attached to it. So we have a flute, this high pitch, and then you'll hear it change. Hopefully you can hear it. So very low and then coming out. Now this is assigning something more complex, playing a song over it. This is a feel for the sound. You can do a lot of different things by assigning different sound profiles. So we wanted to do a test run. This was originally designed for the 2017 solar eclipse in North America. So I was in Jackson Hole, Wyoming, and I had a device there, and I was able to play it locally and then stream that to over the internet, so people around the world could log in and listen to the sound of this eclipse. And then we had 2 other devices in Kentucky in the path, and they, stream the sound locally at their events, and they also collected data, so we can make this plot here on the right of brightness over time, and you can see the eclipse here where it dims. So it was a great success. And then in 2019, we were awarded a grant from the International Astronomical Union. They gave us money to build and distribute 20 devices for the upcoming South American eclipse in Argentina and Chile. So Beatrice led the, like I said, led the efforts in Argentina. Her and her team built these devices on site and distributed them across museums and universities, observatories. They're all listed here and shown on the map. In blue here is the Chile sites, and red is the Argentina sites. And then Pauline and her group led the Chilean efforts to distribute, and Soleil and I built those devices that we sent to Chile. And so it was a huge success. There were a ton of events and thousands and thousands of people at these events. And the big takeaway for me was that this one device, one low-cost device, can impact thousands of people. So one of my favorite images, because I think it demonstrates it so well, is here on the left. It's at La Portada Stadium in La Serena, Chile. And there's thousands of people in the stadium, and there's one device on this table in the forefront here, and that device is connected to a speaker, and that speaker is outputting the sound to all the people around them. So, you know, making this event much more accessible. So building on this, you know, there was another, South America got lucky. There's another great event that just happened December 2020. And obviously we were in COVID and things weren't the same. So the events couldn't be quite as big, and, you know, it hindered some of the distribution, but what an amazing effort again from Beatrice in Argentina, who redistributed these devices with her team. And some of those devices or locations are listed here. They also led a lot of training workshops to kind of educate teachers and users on how to use this. So huge thanks to her and her team. Some of them are listed here at the bottom for persevering during the pandemic. Same on the Chilean side. Paulina and her team won this wonderful grant from ESO and Gemini, and they built now over 100 devices. So they really worked hard on kind of improving the cost and customizing cases and customizing some of the software as well. Some of their devices, they have a few versions, are as low as $25 now, which is incredible. The sound clips that you heard earlier are showing some of those custom cases. So here's a few pictures and another plot. So in Argentina, they were able to collect some data at many of the sites, and I always enjoy just seeing the images from the events. It's wonderful to see everybody enjoying and benefiting from these devices. And the same on the Chilean side. They have all these different color cases, which I enjoy. And the kit shown on the right here, LightSound was part of that kit that was distributed from the ESO and Gemini grant. So we're thinking forward to the future. 2024, there's going to be another great, North American eclipse going through Mexico to the northeast of the United States. And we hope to get light sounds across this entire path. Soleil and I developed our own workshop, a 2-day workshop that we did at the American Astronomical Society for participants on teaching them how to build and use the device. We're participating in the AAS Solar Eclipse Planning Task Force. Just want to educate people and teach them how to use these devices. We have one other device called Orchestra, which is very similar, but the light sensor now is color, so it outputs sound based on the wavelength of light. So blue light has this high pitch and red light is low pitch. One of my favorite things about it is you can flip a switch and turn on an LED switch, and the user here is now scanning a poster, and that LED is reflecting light off the poster, and the color is being sensed by the sensor, and the user can tell what color the poster is. So I just think there's a lot of potential for this project. Here's some QR codes and some website addresses to download and get more information on this, and my email address. Please feel free to reach out, and we hope you'll consider using some of these events, these devices at some of your upcoming events. Thank you.